welcome to the lecture Data Warehousing and Data Mining Techniques. Since this is a lecture that is also recorded and transmitted for the use in the Information Technologies and Information Systems course of study, this will be an English lecture. And we will deal with a lot of different kind of things that are very prominent in today's enterprise systems mostly. So data warehouses are at the core of enterprise information management, and data mining techniques kind of tell us what is in the data. So tell us how to use the data, how can we get insights, how can we get business intelligence. So this is kind of what we're trying to do in this lecture. So how many of you are computer scientists? Okay, 6. How many are Management Information Systems, Wirtschaftsinformatik? Okay, yeah, so it's like half-half, very good. So what we will do is a just short introduction to give you an overview, to show you some of the features of the system, some of the uses, and give you a brief overview about what we are trying to do here. So the lecture will be starting today, and it will be 3 lecture hours because the exercises are kind of included in the lecture. So there will not be an individual exercise date where you get some insights in your exercise sheets, but it will be integrated in the lecture. And we have the detour concept at EFIS, where we will give some historical background, some detailed information about products in the marketplace, open source products or something like that, so that you get a little bit of practical experience with that, which is not too straining in terms of theory, which is not too difficult, right? But just gives you some time to lean back once in a while during the lecture and just see what happens, just see what something means in practice and how it can be used. Depending on your Prüfungsordnung, the lecture is 4 to 5 credits, usually 5, if you are in the new Prüfungsordnung, and the exams will be oral written. I mean, if we stay in this kind of class size now, this is about 12, 14 people, we can do it orally, which is easier for everybody. We had kind of some years where we had like 40, 45 people, it would be easier to do it in a written scheme. There will be homework, we will have exercise sheets, and it's not mandatory, you know, like so you don't have to qualify for the exam by having 50% of the points from the exercise sheets. Nevertheless, I would advise you very strongly to do them, because sometimes we'll do a lot of algorithms, we'll do a lot of things that become much more clear once you have done it, all right? Once you've interacted with some data, and it will be toy examples that are not too difficult to do and not too difficult to actually make. But the algorithms will be clearer. It will become clear what's going on, and so this is kind of what we're hinting at. So that will be. There are some holidays. We have the 1st of May. We have a Thursday lecture, which is in summer always a little bit of disturbed by the holidays. So the 1st of May, Labor Day, will be the first holiday. 29th of May is Christ Ascension, so also that will be free. And then there's the excursion week. Is somebody going on excursion? Or can we have this date? So would you be okay if we take that date? Yes? Okay, then we will do the lecture also in excursion week, because we are very short due to 2 public holidays over the lecture series in total. It's no problem, so if somebody decides to go on excursion, for some other subject, no problem. We will record all the lectures, right? And so you can just work it out. It's quite easy to find. So that's that. The recordings will be in a timely fashion published on our website. So there's a website at the EFIS, general website for teaching. And if you go there and find the lecture, you will have all the new information, all the current information about the lecture itself. You will have the slides, you will have the video recording, and you will have additional information, papers that get some points across, literature that you might want to look up if you didn't get something in detail or something like that. These are the places where you can look it up. If you need specific books that we recommend in the literature, we got them at EFIS, so we do have our own little library. So if you want to have a book from there and want to look it up, want to look up things, that's not a problem. Just ask somebody who's around and they will give you access to it. Right? Any questions with respect to the organization of the lecture? No? Everything's clear? Well, if something comes up, just, like interact with us. I want this to be an interactive lecture. So if you don't understand something, if you want to know something in detail, if you have a question, need a clarification, just, step in and we can talk, right? In the lecture. So few people here that this will be possible. It's different from the relational database lectures, like where you have this huge lecture hall, like with 200 people, and everybody is kind of making noise. But here we can really discuss things and can really find out about things together. So this is kind of good. Then the usual motivational pep talk. Why should you be here? The reason why you should be here is what we learned from enterprise management. Because we've seen a lot in terms of financial crisis recently. We had all the banking crisis, the Lehman Brothers went down the drain. We had a lot of stock market analysts that worked with rather big volumes of stocks and killed some companies by just selling off huge portions of stock market. So basic stocks. We have the financial crisis in Greece, where more was spent than came in. So and that's mostly economic crisis that is to some degree foreseeable, to some degree predictable. And the question is always, do you know what your data tells you? And in most cases, one can say no. So people have no idea what their data tells them. They just accumulate a lot of data, and the more I hear about big data and the more I hear about all the companies having big data problems, well, let me tell you, they cannot deal with the data they have right now. There's no reason to go into big data for them, because if they can't manage what they have already, right, there's no point in accumulating more, which will be equally useless. And data warehousing is one of the ideas that is at the base of company decisions, of enterprise decisions. So decision support systems is kind of trying to give you an objective base for good economic decisions, right? And this is usually why you don't store your data in a normal database, but you want to analyze the data. You want to have access to your data not only in tabular fashion where you can select from where or something like that. You want it to be analyzed in an economic sense. And this is what data warehousing is really all about. So data warehousing, online analytical processing, OLAP, is very important because the data is usually not obvious in companies, right? If you want to know about a trend, Don't wait until the trend strikes you and everybody, all your competitors are doing something along the lines, or you're bankrupt because you're hit by a crisis that you didn't see coming, right? But detect trends very early, right? Detect trends with respect to different subjects in your company. You know, you might focus on the customer. You might focus on your products. Maybe they are outdated, right? Or you have to get into new customer segments. You have to focus on certain time, on certain timeliness of the market, on certain areas. So China may be the next big market, or is currently the next big market. So what will be after China? You know, like what is up and coming? Indonesia, Brazil? Well, nobody knows really, you know. But there are some trends. There's data that could predict at least some of these things. The earlier you and your company know about these things, the easier it is for you to react, right? Because in two times. First, to do something that is sensible, you have to be aware of what is around. And the second thing is that once you are in a responsible position in a company, you have to get your point across to your colleagues, to your boss, right? And tell them, well, we should invest in that market, or we should drop this product line. And the first thing they will ask is, why? It was selling good, right? So why should we drop it? And then you can pull out the statistics and say, haha, I see this trend, you know, like it's going downhill. And this is kind of the idea behind data warehousing, data mining, that you get a glimpse of the future at an early stage and get the hard facts, get the hard data to actually get the point across and put some facts behind it. And there's another reason why you should do that, and that is because we all love databases. You all did the relational databases. That was the mandatory course on bachelor level, and you always wanted to know what to do with it. And I tell you what to do with it. You can become a data analyst if you know how to use databases correctly, right? You can get all the important information for the business, and actually these information data warehousing architects, data analysts, data scientists, right, are highly paid positions, right? So customers and companies are very keen on these people. And I just had one of my PhD students, and Volkswagen was actually before his PhD studies are finished. He's focusing on data mining in his current research, right? And Volkswagen was at the door. They were really running in the door to get him half a year in advance before he will finish, right? With quite nice salary scale, right? And this is why you should learn about this, because it's a very valuable asset to many companies, and you will just be very valuable if you know how to do data warehousing in the correct fashion. And you see that a lot of these, I just got one of these wonderful job postings, right? And you read here a lot of, well, this is the SQL Server experience, SQL, so this is normal database stuff, this is what you all know. But then it comes, right? Data architecture, data modeling, data warehousing experience, OLAP, analysis services, reporting services, experience with data marts, staging, ETL, and so on, and so on, and so on, right? And this is what we're going to cover in this lecture. Exactly this kind of experience is what we're going to cover in this lecture. Good. Recommended literature. I took a couple of books that are very good. So one of the old ones, the Justified and Ancient, is the so-called Inman Bible, Building the Data Warehouse, William Inman, which is kind of a very good description of what actually happens in data warehousing. How is it different from normal databases? How do you have to structure the data warehouse or the business data, the company's data, to make it useful, to make it most useful to your analysis services or to your purpose, what you're trying to do with it. There's one that is a little bit more practical even, so not only on the structural level, but on the implementation level. The Data Warehouse Toolkit tells you about some of the tools and how to do that. That is Ralph Kimball and Margie Ross. There's one in German, if you prefer German books, Data Warehouse-Systeme from Andreas Bauer and Holger Günzel. This is rather short, this is rather brief, very brief description about what data warehouse is about. The basic concepts are there, but the other two books are kind of in more depth. They offer you more details, which is kind of good. And then there's a couple of more focused books. One, again, Ralph Kimball, the Data Warehouse ETL Toolkit. ETL is extract, transform, load, which is one of the basic processes in data warehousing. So this goes very strong into how to do that, into the actual process. So that's kind of very nice. Then there's Eric Thompson, OLAP Solutions. OLAP is online analytical processing. So this is at the heart of the actual analysis task. Very good book for that. And then there's one that is, again, a little bit more open, Data Warehouse and OLAP, also very much on the analytical scale, Robert Rembel and Christian Concilia. So these are kind of the books that I would recommend for the lecture. Yes, please.
Do I have to work on deep knowledge by reading all these books, or is the lecture enough to get a good mark, a very good mark?
A very good mark. Well, that depends on how deep you understand the lecture. I mean, the lecture is of course enough to get a very good mark. But of course you should care about getting very good knowledge, and very good insights, and very good experience, because this is what studying is about, not good marks, right?
Yes.
So the books will help you to understand what I'm talking about, right? Because some of the basic assumptions, some of the things may seem strange sometimes, and sometimes it's just good to get it from a different perspective, right? Because if I say, you know, like, okay, this works like this and like that, it may be clear for me. The question is it really clear for you, right? And then, of course, you can ask and we can interact, but still, I have a certain view on some things. I do have a certain idea about things, and you might just want a different access to that. You might just see, you know, can I have it from a different point of view? Can I have it from a different angle? So I understand what's really behind it, right? And in the end, we're probably doing oral exams, right? And what I care about is not about learning the slides by heart or something like that, but understanding the concepts of data warehousing, right? Deep down, how does it work? Why do we do it in that way, you know, and not in a totally different way? Is it just a new name for relational databases, or is there something different going on, right? And why is it different? How is it different, right? This is kind of what I expect to hand out a good mark. And experience, and knowledge, and value for the later employer, right? Good. Anything else with respect to the organization, books? Good. Good, that is that. So today we will do the introduction. I will show you some of the basic concepts, the very basic concepts of data warehouse. We will talk a little bit about what you need it for, who uses it, who are the user groups who are the stakeholders, something. And then I will tell you a little bit about the life cycle of data warehouse, how it is built, and how does it actually work, right? So the basic question when you first heard about the lecture, what is a data warehousing, you probably ask yourself, what is a data warehouse, right? What makes a data warehouse in contrast to just a large database, right? And the basic answer is, well, that's it took some time during the 90s to figure out the actual differences between big databases and data warehouses. Data warehouses started off as just being defined by the size, and people said, well, yes, we do have all this business data and we have to store it basically not distributed over the whole company, but we should put it together in one place, like we do with our products, right? So we do have a warehouse where we store our products, everything that we produce, and it's stored in one place so we can access it all the time, you know, like and deliver it to the customers. Why don't we do the same with our data? And would we need different structures than the basic relational databases that we already have? And this was the question that was kind of beginning to turn up. So what we can say is that data warehouses are usually very big databases. On the other hand, not all large databases are data warehouses. So it's an implication, but it's not the answer. Size matters, whatever somebody tells you. So databases range today from the tera to the petabyte scale. So you see it's quite a lot. Currently people are talking about exabyte warehouses. We are not yet there, I would say. So currently what you see in practice is gigabyte, petabyte, depending on the size of the enterprise. What you obviously have to do to store such a lot of data is you have to have strong servers, you have to have strong storage area networks, and you have to work with the data, you have to analyze the data, which means you need a lot of computing power. And currently the hardware business has taken a new stance towards it, so there are different products like IBM's NetTeaser that are specifically designed to work analytics on big data clusters. So that is kind of what you have to do. So basically, we can say a data warehouse is a very big database ranging gigabyte, petabyte, or terabyte, petabyte scale, and is kind of very strong computing system. But it's more than that, because it does not collect data according to some data model that you have chosen to model what we in relational databases call a mini world, you know, like, or your very view of the world. But what it should offer is a collective data repository for the entire enterprise. So not your view as a data from the accounting angle, or from the marketing angle, or from the product management angle, from the product development angle, but the complete enterprise. All the data there is in the enterprise, be it product data, be it customer data, be it employee data, right? All the different ways. And that means that all the operational data, so what your company did, should be there. Well, in terms of snapshots, right? You get basically a snapshot over time, what happened. And at the base of that is the extract transform load process. So I think in 2 weeks we will go deeply into the extract transform load. And the idea is basically that you have a lot of servers that work with operational data. And to get this collective data repository, you have to do something to get the data from the mostly distributed kind of way that the operational data is maintained to the big data repository, right? And once you have this collective data repository, you can basically do analytics on all aspects of the data, be it customer segmentation, be it product development, be it, I don't know, trend setting for who buys what or something like that. You know, everything like that can be done. And this is kind of the idea. Of course, it doesn't help you to say, well, I have this data here, right, and this is like the operative data, and I have this big database here in the middle, and I will just shuffle it on, right? Because then you would just have a heap of data, a big lump of data, which doesn't really help you. But you have to prepare the data for being integrated. You want an integrated view of all the enterprise data. And this is called data cleansing or data cleaning, where you kind of look at your data, where you pre-aggregate some kind of data. We will go into that a little bit deeper in a couple of lectures. So this is kind of the idea behind it. If you consider the normal data management that you have in companies, the operational data management, the idea of a data warehouse is to provide a solid knowledge base, a solid database for tactical, strategical focus, so short-term, long-term decision making. And since these are very complex operations, you can usually only have a small number of transactions running in parallel. You know, like it's not like Amazon shopping, you know, where the whole world shops at Amazon at the same time, right? And then you have millions and billions of transactions per minute. But this is rather more complicated. You work with the data in a very intelligent fashion, and intelligent in computer science usually means time consuming, right? It means expensive. And that means long-running, large transactions that span kind of over the idea. As opposed to your operational data, where you have large transaction counts of short duration, usually in the data warehouse, you have a tactical strategic focus, where you have a small number of transactions that are usually long-running, right? This is the idea about the timeliness of data. I also want to give you some definitions, some formal definitions of data warehousing, because data warehousing came into being beginning of the 90s, I would say, where the people for the first time had this idea of, well, we are now able, we have this IT infrastructure, the IT landscape that kind of wildly developed in every company. So everybody, you know, like the human resources department had their own database where they kept all the information about the employees, and the marketing had a customer database where they kept all the information about the customers, and the product development has all the technical specifications of the product in one place, you know, like, and the systems didn't really talk to each other, right? But then, beginning of the 90s, especially with all these idea of connecting via networks, connecting via the web, being more service-oriented in enterprise infrastructures, the people began to say, well, this is actually not what we can manage. This is actually not what we can maintain, because we need the integration of data. This is kind of the interesting thing, right? Rolf Kimball, who's one of the old experts on data warehouse, basically said, well, it's easy to do all this analysis and to really work on the data. What you need is a copy of the transaction data, of the operational data of your company that is specifically structured for query and analysis, right? So you already have the analysis task in mind when you structure your data for being put into the data warehouse, right? And the structuring should still be flexible, so you can have different kinds of analysis. If something new comes up, right, you should be able to also facilitate that. Bill Inman is often called the father of data warehousing, and he has made a definition that's a little bit more detailed in what it says, right? And he said a data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management's decision. So, query and analysis on one hand, this is what the data analysts do, Management decision, on the other hand. This is what you need the results of the data analysis for, right? So it's just different views on kind of the same thing. Interesting are these terms here: subject-oriented, integrated, non-volatile, and time-oriented. If we look a little bit closer on them, we find that, for example, subject-oriented means that the data in the data warehouse should be centered around a certain entity, well, or event, or person that you want to look at in your analysis, right? It could be the product, for example. You could focus on the product, and then you need all the data, who buys what, to make a decision whether it is or drop it, right? But you also need the technical data to see whether a product line is outdated. And then you can make trade-offs and say, well, do we have to redevelop it, right, to make it a little bit, to modernize it? Then the sales might go up. Or is it still selling well? You know, like, and our competitors don't have anything similar. So why should we invest in development? We can save the money, it sells anyway, right? For all these decisions, you need a lot of data. So you have to organize the data in the data warehouse that it is focused on these elements, real-world events, objects, and that it links the elements, right? So the technical aspects of a product have to be linked to the sales. At first sight, they have nothing to do with each other. But when you think about it, when you think, well, what sells better? A highly developed, a very modern product, or an old-fashioned, outdated product? Right? If you think about it, this kind of data has something to do with each other. Technical specifications have a certain influence on the sales point. Not always. I mean, Apple keeps on selling outdated products for years now with good marketing and good kind of promotion. You can kind of sell everything, right? But that's a strategic decision. And being aware of what you do helps you have reason for this strategic decision and make clever strategic decisions. So this is kind of what I'm saying here. Typical subjects in the data warehouse are usually customers, so you focus on what the customer is about. You can look at microgeographics, where does the customer come from. So whenever you go to I don't know, Saturn or something like that, one of these big electronics chains, right? More often than not, they will ask you at the cash register for your zip code, right? Why do they do that? What has your zip code to do with the product you're buying? Well, in an integrated view, they might want to see geographically which products are preferred in what areas, right? So they can plan specific shops or whatever, right? I don't know what they do with the data actually, but they collect it. They want it. The product, of course, the order or the different orders, claims, warranty information, accounting information, taxes, right? So there's a lot of different topics that you could focus your warehouse on, or a warehouse on. A company does not necessarily have one warehouse, but may have several of them that are focused on different topics, that are focused on different subjects, right? Second part, if we go into the customer as a central subject, then you organize all your data by customer. So you might have data slices for different years, right? You may have kind of base customer data, which is all the information about the customer. You may have activity data where you record how often did he buy something, or did he buy the same products, or did he kind of exchange products very often of the same type. So does he always want the newest and hippest kind of stuff? And of course, what you can do with that is very easy targeted advertisement. You know, if you know a customer always bought the newest tea set or something like that, and something new is coming up, why don't you send them a reminder or a short leaflet, you know, like saying, oh, the new generation of TV sets is in, would that be something for you, right? And this is happening, you know, like we are on a very personalized scale. So why not basically building your data along these ways and kind of having all the data about the customer in one place, right? And the interlinking is basically the idea that connects the data in the individual tables, the different aspects of data with each other. So you can really couple the geographic information about customer, about how often does he come to your shop, you know, like, so people from Braunschweig may go to the Braunschweig shop more often than people that are living, I don't know, in Helmstedt or in Wolfsburg or something like that, that have other options or don't come to town very often, right? Second term was integrated. The data warehouse contains the organizational data, and not just, you know, like what is considered interested, but basically all of it, right? Or most of it. And to have all this data in a single place, you need it to be consistent. You can't have decisions that are basically built on contradictory data, right? So if you build a statistic as a data analyst, okay, the customers in Braunschweig bought this and that very often, you know, and somebody pulls out a statistic saying, you know, like, no, they bought something different very often, you know, this is not a very good management decision, you know, this is not a very good base for good decisions. So what you need is you need to have true data, you need to have clean data, you have to have correct data, and the data should not be contradictory. So it should be integrated and made consistent. What often happens is that you have different encodings for operational data. So if you have a web shop or something, you may, or the designers of the shop may encode the gender of somebody as being male or female, or they could have said M and F as abbreviation, or 1 and 0, you know, binary decision for that, right? And it all means the same. So in the data warehouse, it should be represented in the same way. Because the query you pose on the data warehouse should not be, well, depending on where the data come from, it should be M, or it should be 1, or it should be male, right? You just want to say, well, let's stick with male. And the whole data warehouse considers gender male being represented by male, right? And not by 1 or by M or by something totally different. That happens very often if you have multinational companies that are measuring in different ways, right? So if the size of a product is given in inches or centimeters, that may have a strong influence on what you do with the data. Well, that may have strong influence on interoperability of the data. So actually, the Challenger catastrophe, the explosion of the Challenger rocket, was due to a inch to centimeter conversion that failed. Right? It was a data type mismatch, semantic data type mismatch. Right? So this may not happen for your company, but still, it's good to be aware of that you have to mix it, right? Same goes for different languages. We may say männlich weiblich, you know, they say male female, right? And it may be encoded in different softwares and different interfaces in different way, right? So you have to kind of integrate it. You have to kind of look at it very closely. Non-volatile means that the data in the data warehouse, as opposed to typical databases where you kind of keep track of your stock in some product depot, or you keep track of the movement of a stock, you know, like in the stock market or whatever. where the values actually change. This is not what you want in a data warehouse. You basically want the data to show you the full picture. If a customer bought a product, he has bought the product. Even if he returns it the next day and says, well, no, that wasn't for me. You want to have this information rather than the information, well, the customer actually did not buy the product, right? You want the complete information because you could have an analysis on how many customers return the next day. Very important, for example, for online shops at the moment. Everybody probably knows Zalando due to their very aggressive advertising. They have a big problem that people just order things, try them, and send them back. With all the shipping and all the ordering procedure, you know, like being paid by the company. Right? Having an idea how often that happens and how often people actually buy is absolutely crucial for companies like that. So you don't change, you don't update the data in the data warehouse all the time. You just append. You just record what has happened. So data is hardly ever overwritten or deleted, but it's collected and made read-only, should not be tampered with, so you can do all the kinds of future analysis that you might want. Yes, please.
Well, you said data is not updated. What about outdated data? I mean, wrong or not actual data. If we, for example...
Well, that's different. You know, like, I mean, data is hardly ever outdated because then it's historic data and shows what happened, right? And it may have value, you know, what happened 20 years ago. Well, for example, think about the stock market. Stock market analysis does long-term profiles, right? So you see something like this stock has certain cycles. Every 5 years it kind of goes low, you know, like, and then it starts to build up, and then there's the next crash. So if I want to predict the next crash, I rather have the 20 years old data, right? So it may be outdated to some degree, but it's still interesting. It's different if it's wrong. You know, if it's incorrect data, then you may have updates in the data warehouse. The question is, how do you know, right? Who remembers after 20 years, you know, like what happened to a certain data set or whether a certain customer bought something or not, right? So actually, if you look at data warehouses in practical applications, right, in the big companies, you will find a lot of crappy data. And you will find a lot of compromises that have been set. So I had a student, and it was actually funny because we were working with a big company here in the Braunschweig region, and they had a working data warehouse of several petabytes, and they had big problems of integration in the data warehouse, you know. And he basically told them, so why don't you get a global schema for your company, and then you have the integration ready, right? And the guy started to laugh, you know. He was just, you know, like, yeah, sure, build a global schema for a company. It doesn't work, right? This is theory, right? It would be nice if it would work. But in practice, it's very hard to do these things. And some of the issues that we are dealing with here, and some of the theoretical nice to have things, can be understood in the way of guidelines, not understood in the way of absolute kind of ideas, right? So you should try to get it as integrated as possible. You will never, not even in small companies, have 100% integration, right? So for example, one example that I tell very, very often that I find nice is the warranty database of a big car manufacturer around here. And they have the basically how much different parts were replaced at a car, right? And so then it's kind of cross-connected, cross-linked with how much these different things cost, right? And then they can do billing and all kinds of things with that. And when I looked into the data, I got access at one point, and when I looked into the data, I found out that they built, like they changed a filter or something like that, but they did not change one filter, they changed 0.8 filters. I was kind of like, an 80% filter? I mean, how do you change an 80% filter? And the guy was saying, well, no, it was one filter. So then it should not be 0.8, it should be 1. Yes. Actually, yes. But if I say 1 there and not 0.8, and it's linked to the prices database, which is fixed, then I could not give the customer 20% rebate. Right? So the users will use your data warehouse in very creative ways to get around the products, the constraints that were put on the data warehouse while constructing it. Right? And sometimes it's not possible to kind of fully integrate something or to make it beautiful, right? You have to work with what is there. And this is something that you will see in practice very often, like, so they're very well-maintained data warehouses, but you will also see the bad and the ugly ones, right? Making it a little better is always what you're striving for, okay? Good. So basically, the idea is you load the data, you don't update data. When changes occur, you do a change request on the data warehouse and notice, okay, the customer has bought, he has returned, he has bought something different, and you link these data items rather than saying, okay, this sale is erased from the data warehouse, right, because it was returned. This is kind of the idea behind it. Last thing, time varying. The changes of data have to be tracked. On one hand, this is due to the idea of that you consistently and all the time update the data warehouse, and you need this time information to consider the time span, for example, with which somebody buys products or something like that. And the reporting that you do, the analysis that you do on top of that, can consider this time value, right? And the question is really, what time horizon do you have? Are you do you have to know about all the sales in your shops in a minutely fashion, right? Or is the day what you're interested in? Or do you do monthly reports, right? And it's okay to know what happened in 1 month there, right? And this is kind of the basic idea. Operational databases have very short time focus. So if a product has not been returned 4 weeks after the sale, then it will probably not be returned. It might still break down or something, but that's rather rare. So an operation in day-to-day business of a company is usually like a month. You have to consider something for a month, and that happens. It's like your emails, You will either deal with an email within a week or 2 weeks or 3 weeks, right? Or you will not deal with it at all. It's very rare that you say, okay, this email is important, I have to do it in 3 months, right? Very rare. In operational business, same. With data warehouses, this is different. Data warehouses have a 5 to 10 year horizon, so knowing about the development of a company is kind of interesting on the short scale on what happened last month, but only if seen in perspective with what happens, like for a longer time span. Did we develop well? Did we expand over the time, right? Are these kind of investment costs that we have to take at this moment, or is this kind of a bad sign for us to go down the drain, right? So this is kind of the idea behind that. Time varying. Good. So general definition, a data warehouse is a large repository of some organization's electronically stored data that is specifically designed to facilitate reporting and analysis, with all these different points that we just covered. A database, typical, resides on computers that are dedicated to this function, so it's a very bad idea to put it on top of the web server or on top of some like operational systems and say, and there's the reporting thing still, because then everybody will go, okay, how does it work together? I need this data now, right? Can I cut down the operational systems, right? Nobody can sell anything in my shop because I want to do this this kind of analysis here or something like that. But should be dedicated hardware, should be closed off from all the other systems, because this is the central information of your company. Do you want somebody to mess with it? No. Do you want to see other people see it? No. Do you want to have the customers know about it? No. This is your data. This is the core of your company, right? If somebody messes with this data, your business decision might go wrong. So keep it cordoned off, and beware of wild tiger signs around it, right? So it's not a good idea to make it too accessible to people that have nothing to do with it. Since it's rather big databases, you usually need enterprise scale database management systems, Oracle, IBM DB2. There are some specialized products, for example, Teradata. That was the first Tera database server that was specifically designed for that idea. Microsoft SQL Server. You see a lot of the big players also in the data warehousing area. You have to retain the data for long periods of time because you have this 5 to 10 year horizon. Like you have to accumulate, consolidate data. Many systems coming in, human resources department, product development, customer data, sales points data, right? Coming in from different directions into the data warehouse. And you have to consolidate that, you have to make it consistent, you have to integrate it. And you build it around your carefully designed data model, because what you model in the database is what you can do with the data, right? So if you don't have a possibility to give customers a discount on something, you will figure out ways of just having a 80% filter exchange or something like that, just to get the price right? So it's kind of tricky in that respect. Design your data model in a very good way. And now we will go into the first detour. This is where you can usually lay back, relax, and get Kinder, and she will tell a fairy tale today. But the interesting thing is the fairy tale is true, and it's stranger than fiction.
Yes. So relax, but no sleeping, even though it's a bit early. So I'd like to welcome you to the first detour of our lecture. And the story I want to tell you about today is basically the first data warehouse, or the first data warehouse that was over 1 terabyte. And this was actually deployed by Walmart. So Walmart is a huge corporation that is situated in the US. They run a large number of discount department stores. And at one point in the 90s, what they wanted to do is they had a large amount of data, and they wanted to start to take these strategic decisions that will push their corporation even, giving them a higher competitive edge. And at one point they said, well, we have a large number of discount stores all over the place. We want to keep track of the sales that are happening simultaneously as they're happening, and accordingly get a picture of what is being sold, where, when, and then they can make these strategic decisions. Around the same time, we had Teradata, which in the mid-'80s, they were named as the product of the year. And Teradata basically offered analytical data solutions. And they started off at the late 70s. They were basically born from the cooperation between Caltech, California Institute of Technology, and at that time they were negotiating or having cooperation with Citibank. And while research in Caltech showed the how to do, Citibank provided the reason of why you should have these kinds of solutions. And so Teradata was born, and just took them 5 years or 6 years until they were top of the market at that time. And it was then no surprise that Walmart went to Teradata with that question, and Teradata had the solution for that, and they did a sale, so they sold, and yeah, at that time Walmart voted for like so 1,500,000. I mean, for Walmart at that time, that's nothing, and this was the solution that Teradata gave them. And it took a couple of months, so you can imagine they had a large amount of data. So months of loading all the data inside carefully. Now the beauty of the product of how they wanted to act starts. And you get one of these executives, and of course this is only an example of what, for instance, might have come into their mind. So they want to ask about a certain product, about a certain promotion that they did, to see how successful it was. And it could be something like this. So they had a Colgate promotion. Colgate is a toothpaste, and it was directed at small towns, so towns whose population is less than 40,000, for instance, and they just want to see how well it did. And so the executive comes up with this nice idea. He wakes in the morning and says, I want to know how the promotion was. Let's see if it was worth it or not. And he goes to the special department in his in Walmart Corporation, and he asks them to run this query. And you get this really intelligent SQL query guy, and he translates it into this query. And as you can see, this query is rather complicated. It's not complicated in the sense that we do not understand it. I mean, yes, I mean, you get here, we're checking, we're doing an aggregation. We want to see the quantity of solds for Colgate, which is a toothpaste, and then in smaller towns with the population less than 40,000. But what is complicated here is that you have 6 table joins. Table joins means a lot of time and is rather heavy in the processing on the underlying databases. And the question is, you formulated this question into a query, and you get this nice, a little bit hard, complicated query, and the question is, can you run this on the underlying solution? Can a query like this run, and can you get results or not? Well, why not? It's a valid query, and it will run, and it did run, but at what expense? So as soon as you run a query like that, which is six-way joins, what will happen is it's not one of these simple queries which can actually run quickly and then you get the results within like sub-seconds or a second. It will rather take some time. And while you're processing that, so it might take up 10 to 20 minutes, remember that Walmart is an operation. People are buying, people are buying products, and at the same time, the cashiers want to record these sales in the database, in the database. So while this query is running, the cashiers are trying to, you have a huge line of customers, and the cashiers are trying to put the sales, and it's not running, and it's hanging up. And of course, you get a lot of impatient, angry clients who wants to run to the next store or want to finish their sale. And so the query runs, but at the expense of huge losses of money, because you're getting times during the day where you cannot process a single sale throughout all of your department sales. And of course, as you can expect, you're getting a lot of angry people at Walmart, right? I mean, it's a solution that they bought and they expected something, and it's not what they wanted. But on the other side, for the guys from Teradata, they knew exactly what they sold Walmart. And what they sold Walmart is, yes, it's a database that allows them, it's a data solution that allows them to process sales and do queries at the same time. However, not these types of queries. So basically, the queries that the solution that they provided are so-called OLTP, online transaction processing, and we'll come to that in in the next slide. On the other hand, what Walmart was trying to do, they were trying to do these so-called decision support system queries, where you're trying to get an idea or an insight from your data. It's a little more complicated. It's not your traditional number of products that were sold today, or they're rather complicated. So, I mean, we don't know exactly what happened, but this is what you can imagine. A lot of angry talks, a lot of discussions. What can we do? This is a fault in your system. It's a bug. And actually, it's not. I mean, that's how the system should work. And this is basically so-called pessimistic locking. So this is to make sure that the integrity of the data is fine. If you're doing an update somewhere, you have to lock the data to make sure that this update is done, is committed in the database before someone else does something else. So a lot of discussions, and at the end there was another sale, and this is when they sold them a new solution, which is the data warehouse. And this was the first data warehouse of 1 terabyte. And even until today, so in 2013, Teradata was still in the lead for selling best data warehouses at the most competitive prices. So from that point until today, they're still ahead of the pack in data warehousing solutions. So you already heard me mentioning this term here, online transaction processing. And this is the kind of processing that Sybase, that Teradata, when they sold their solution, they expected these kinds of queries to run. Well, basically, IT systems can be divided into roughly two. Online transaction processing, OLTP, and OLAP, online analytical processing. And you can roughly say, in a broad sense, that systems that runs OLTP, they provide the data that you will place in a data warehouse upon which you can run OLAP, which is the analytical queries. So in online transaction processing, these kinds of systems are fit for transactions that are small. You typically have huge page, a large number of users that are running the system with many queries, but simple queries, queries that can be run in small time, in a very fast manner. And they're basically run on the operational data stores, which basically hold a snapshot of the current business. So these kinds of systems typically represent the current state. So you might have in the underlying database the data from the past month, but you will not have this all of these big historical data from 20 years ago. No, it only reflects the current state. Maybe it extends a little bit, 1 month, 2 months, but not more than that. So it's typical for data entry and retrieval. You will have a lot of updates, but like I said, transactions are small and rather simple. On the other hand, the online analytical processing, now this is what Walmart wanted to do. They wanted a query that would give them some kind of an insight for them to do a decision that would help them get this competitive advantage in the market. So it gives you insight of what the data is about. What can you actually understand from the data? Getting extra knowledge. And this is typically useful for, like what we've been saying so far. So for enterprise resource planning, to find out what you need to do, how you need to plan your resources, what is being used, what resources do you have that are rather stagnant and you don't need to get more. What about capital budgeting or marketing initiatives? Is there a certain place here, a certain region that seems to be, like for instance Primark, if you go I was just at Hannover yesterday, and you always see these people going from Braunschweig to Hannover, and they always come back with Primark bags all the time. And now I heard soon that Primark is opening in Braunschweig, and it makes sense. Every time I go to Hannover, there's always it's always these, and I didn't know about that store, and I just knew about it because I always saw the people with that. And of course you don't have people in the trains checking, okay, who from where, which city is coming and buying from our store, but rather they're getting information at a cashier, like a zip code or something, and then they realize, it looks like there's a lot of young people in Braunschweig, mostly students, so good prices is rather attracting for them, so it's a good idea to go and open a store there. But of course, I notice it because I go to Hannover. For them, they don't have people running around checking. So something like a data warehouse or analyzing the underlying data gives them an insight, and then they can do a strategic decision like that, which is based on actual factual data. So we've talked about online transaction processing, online analytical processing, and both of these transactions run on different underlying data solutions. So on the one hand, online transaction processing runs on operational data stores, and the OLAP runs on data warehousing. So as we've said from the Inman definition, that typically in a data warehouse you will have mostly reads, so you will not be doing any updates, and this helps preserve the integrity of the data. You don't want anyone to go in the historical data and change something without you knowing it. You want to be aware of what happened, and something like if a product was returned and you want to keep track of which products were returned, maybe there's something faulty in that certain product. You want to keep that, so you don't want to change it. On the other hand, operational data stores, you typically have updates. You have inserts, updates, deletes, so a lot of these transactions. A lot of and the transactions are many, but rather simple and small in the size. In the data warehousing, they'll be complicated, like the query we saw a few slides ago. However, they're not going to be a lot. So it's not every day or many times a day where the executive is going to come up with an idea or with a query and goes to a query analyst and tell them, oh, I want to find out this product, or I want to find which region here is selling more. It's rather going to be few, but complex. So they take a long time to run. While operational data stores work on raw data, so you get the data and you insert it quickly. On the other hand, the data in the data warehouse, you have to prepare it. Remember, we said it's subject-oriented, for instance. So you want to focus on something, on the customer, on the product, and so you start organizing the data in a certain manner, and you start to summarize the data, to aggregate it, so that it works for the target, for the point of view that you want. Of course, you have to keep in mind that when you're summarizing, doing aggregation, then you're losing a little bit of data, and you have to be sure that on the long run, this aggregation that you did will not affect you, or you will never need this data again, because once you do that, you lose it probably forever. While the operational data stores provides you with basically a snapshot of the current business. The data warehouse will have historical data, and I mean this is reflected in the size of the data. So in an operational data warehouse, it's just what's current, what's happening right now. So it will be megabytes to terabytes. While the data warehouse, you're keeping all of this historical data of your company. So it goes petabytes or even more. Another important difference between these two systems is how you design your database. Anyone here did not attend Relational Database 1 or? So all of you are familiar with the schema here, right? So basically what we did in normal relational database, we had these normalized schemas. And the idea of having normalized schemas was you wanted to reduce any duplication, any redundancy, so that when you do any updates on the database, this is done at one place and it's done fast. However, here you have different entities that you identified in your system that you want to keep track of. You have the customer, the invoice, product, sales, and then you build tables, and you have many tables, and they're rather small in size, and then you basically start to link them. And whenever you have a query, then you want to find out the customer, the invoices, and the products, primary foreign key relationships to do these joins and get the query done. And this works for the relational databases because the queries are simple and then you can do the joins and it's processed rather fast. But when you're working with a data warehouse and you have huge amounts of underlying data, you can't afford to have this normalized fashion and all of these joins that are done. And so when we start to design a data warehouse, the underlying schemas that we use are rather different, and we are going to look at that extensively in the next few lectures. And basically we adopt different kinds of schemas, something called star schema or snowflake schemas. And here you instantly see this subject-oriented definition. So you have something in the middle here, which is the sales, and this is what's interesting for us, the sales. And then you have all of these dimensions that are connected to that, let's see, subject-oriented table. And if you see, this is rather denormalized, which means that you will have a lot of aggregation, you have a lot of duplicates. If you look at the time period, for instance, you have here the week and the period and the year. And we do this denormalization because we don't want to have all of these joins, but rather, first off, normalization was done in order so when you do an update, it's done at one place. We don't have a lot of updates anyway in the data warehouse, because as soon as we load the data in the data warehouse the first time, you load it in different areas, it's probably the same data, and you're mostly doing reads, so you're not updating, so that doesn't bother you anymore. You don't have to be careful that when you do an update, it's done and reflected in all different tables, but rather, since you're doing a lot of reads, it's fine by you. At the same time, it makes the processing quickly, because remember, you have these huge complicated queries and you want them to as possible. So kinds of schemas later on, we'll see it in the lectures. And this is a typical one, so star schema. Another insight that we get from the Walmart is that what they tried to do is they had this operational data store and they tried to run an OLAP query on it, and then they had these crashes in the middle of the day where you couldn't process a sale because they were running these queries on them. And basically what happened later on is that they had a different installation, so they separated both systems. So they had the operational data systems on one hand, and on the other hand, they had this different installation for a data warehouse. And this is typically what is recommended, that you separate both of them, because how you reuse both systems are different. I mean, now you have SAP and they've pushed a new solution called HANA, which is a real-time data warehouse and an operational database. However, it is still for not really big corporation, not on a large scale. They do exist on a smaller scale. You could get by having one system for both of them as well if you have a strong underlying computing power, like a cloud storage or a very big clustering solution. However, it is still recommended to separate both systems, and it works better. And if you want to get more visual idea of what is happening or why this might be problematic, you can look at the hardware utilization. So in the normal operational data system, you basically have a lot of transactions and they're all the time happening. And the utilization of data warehouse is nearing 100%. They're happening all the time and there's a lot of them. On the other hand, in the data warehouse, you have only a few queries that are rather complicated, and you have these peaks. So it's not all the time running, but at one point there's this query that is running about a certain product, and as you can see then it's not constant like in an operation data system. And now if you merge both of these together, so if you want to run everything on the same system, you basically have this peak over here on top of here. And you can instantly see that your hardware will not be able to handle both of them. It's either going to be either this or that, and that's why it would not work. So that's why what happened with Walmart. You had these points of time where only the analytical query was running and the sales stopped. And this is why it's always recommended to separate both systems. Typical questions that online analytical processing might be answering are, these are also rather simple. These queries that are written here can be more complicated, but something could be how much sales for unit A was earned in January. So you want to see if certain products are popular, for instance, at certain periods of time. So some products may be very popular during Christmas time. Think of typical Christmas foods or something that is for the Easter. So keeping track of what is being sold at which point of time, what is popular for which age or which gender or in which countries. All of these decision-oriented decisions helps you get these insights and helps you decide where you should go, what you should stop doing, and what you should do in the future. And these are the questions that OLAP typically tries to address. So they're complicated, but they're rather few. And that's why we typically separate them, because they're complete different functionalities. The question is why they can run faster with a data warehouse, and I think now you already have an intuition as to why. Like we said, the way we design a data warehouse is different than the way we would design a database, and that starts from the very core of how we design the underlying schemas. Like I said, it is denormalized, so you don't have a lot of these joins that needs to be done, so things go faster because the tables are rearranged in a certain way to minimize these joins. At the same time, your company might not have only one data warehouse, but they'll typically have maybe more, depending on what they're trying to look at. So some companies might be looking at the customer, others may be looking at different cities or a different product, and depending on the type of query that you have, you will run it on the corresponding data warehouse, the data warehouse that is organized according to that typical query that you're running. So if you're running a query on the product, you wouldn't go to the data warehouse that was designed to answer questions about the customer, but you will go to the data warehouse that was designed for the product, because you've designed it in a way to give you answers for this types of queries. Next, we'll be talking about typical applications. However, we will give you a little bit of a break now, so 10 minutes, and we can meet here again.
Let's go on with the lecture for the last part today. We want to talk a little bit about the typical application, the user of the data warehouse, so how is it used. You got a basic insight now what a data warehouse is, and we will go into more details during the next couple of lectures to really give you some in-depth information. The typical application for data warehouse is what is often called a business cockpit. You have this online analytical processing, big queries that tell you the answers based on the data, on the customer's data to specific problems. But you also have a second type of application, and that is what is called KDD, or knowledge discovery in databases. This will be dealt with in the second half of the lecture, the last 5 weeks, I think, or 6 weeks, where we go into data mining, where we go into algorithms that make more sense of your data beyond the usual query, beyond pure SQL. And what you can do with it once you discover new data or got to the answer to something, you can get statistics out from it, you can visualize what your data is about, you can use it for reporting, get all the valuable information, all the assets that your companies offer, and then what the current value of the company is, and so on. This is basically what you do with it. So data visualization and reporting is basically the two typical applications that you have. And the idea behind this online analytics process is to provide timely, accurate, and understandable information. However, timely is rather relative, because in our example, the Walmart example, you already saw what happened, right? At the cashiers, time means, you know, your request should be handled in a couple of seconds, right? They should take your products, you know, and just scan it, and then you get the bill, you pay, and then you're out of the shop in minutes. In online analytical processing, you may have very complex query, and it doesn't really matter whether you have to wait for the decision or whether you have to wait for the statistics for a couple of hours or something like that. Usually, it's not that's timely. So if the query runs a little bit longer, that's not really difficult for the most people, because sometimes it can be nice to have information at your fingertips and statistics on your fingertips that are kind of created as you go. But usually you will say, okay, I want to report on something, so do it over the next 3 days, and then in 3 days I have it on my desk or something like that. So this is rather how it works, right? If we're looking into knowledge discovery and the data mining issues, then what you do is you construct models of the data that allow you some amount of prediction. So, for example, you could have a model of the sales, how they develop, you know, like that if a product is new and you hype it, you know, you might have a steep increase in products, and then it gets stable at some point, and then customers start losing interest in the product because they're newer or better developed things, you know, like that are in the marketplace by competitors. So you usually have typical models of how sales will develop for some product, and predicting this model and predicting how much you're going to earn with a product is very influential in how much money do you invest on the development of the product or the marketing of the product or so on. So for planning, this is kind of a good idea. And of course, the more data and the better, more quality data you have underlying your system, the better the predictions will be. So, for example, you could have something like customers older than 35, having at least one child, and driving a minimum, usually spend more than $100 for grocery shopping, right? So they are the people that drive to the grocery store and buy everything at once, you know, once a week, every Saturday or something like that. And this is a specific customer segment. And you can just model them by looking at the underlying data, the basic transaction data, and see whether your hypothesis is right or whether is it invalid. There we go. Nope. Back. Right. One question that's also interesting to see is who are the users of data warehouse, and on the big users is usually data analysts, because as you saw with the big SQL query, not many managers coming from classical management studies will be able to do such complex SQL queries. Neither do they have the time on their hands, nor do they have the skills to actually do it. So it's specialized people, especially in the kind in the sense of management information systems, right, that provide these information. This is why these analysts are very highly paid, because they are very important for the decision processes, and it's mandatory to have one, otherwise you won't get to the data. So you have a very good bottleneck position that will make you very very necessary for the company, which is already good. And the idea of this decision analyst is not only a call by call, well, if somebody wants to know something, I'm building the SQL thing, but rather also kind of a monitoring and a discovery of data. So they look at the data, they maintain the data, and they work with the data, they get a feeling of the data, and then they can predict things that the management did not think yet about asking, and they can point to certain things. They can point to certain things. So the idea is that you work in a discovery process, that you don't work in a guided process where you know from the start where you will end, but you just dig at data, you know, like, and I tell you what I want, and you show me some data, and then I know that was not exactly what I wanted, rather this way. You refine queries, you refine searches, you know, and you explore the data space. You just see what's there, and the more you see, the more you know about what you're going to find. You know, like you explore the possibilities of further questions by giving answers to some initial questions, and then you take a walk through the data that you might not have anticipated totally, right? And this is kind of a typical way of interacting with a data warehouse. And of course, this is also reflections on how the data warehouse is developed. You know, because in classical software development, you start with the typical requirements engineering. That's right. Idea. What the requirements actually are, what you will need in future, what the data will tell you, and what else you might know or want to know about that. So the new requirements, the changes that are coming in, are very hard to facilitate in data warehouses. And this is very often called the data warehouse system development lifecycle, which is different from the classical system development lifecycle, where you start from the requirements and then build the different components that you want to have to arrive at certain results that were predefined, that were anticipated fully, right? In data warehouse, it's kind of different. You start with the data warehouse where you just stuff in all the data, and yet then you start exploring the data, and this is usually done by some techniques from data mining, from some intelligent querying that you do. You interact with the data, and from the interaction you see what is in there, and you start building requirements, what you actually want to see, which reports you want to generate, which reports you want to show to some people, right? So it's kind of the opposite, and it's kind of very often it's called CLDS, because that's just the inverse spelling of the normal life cycle. So that's kind of the idea. So the classical software development or system development lifecycle, you start with requirements gathering, analysis, design, programming, testing, integration, implementation. So you go through all the phases, usually within a loop. Data warehouse, you implement the warehouse, you start with integrating the data, you start querying it, you start mining it, you start doing things, and then you design the decision support system. You factor out the requirements that your decisions actually need and what your management wants to have, right? Because usually when you start with all this kind of enterprise scale questions or enterprise scale requirements, especially now with all the big data problems, right? People have no idea what they're talking about, right? You will more often than not once somebody asks you to design a system or to build something here, well, I want to see what's interesting in the data. Which makes you ask, what do you consider interesting, right? Well, everything that's not normal. Well, can you define what is normal for you? Well, things that are not interesting, right? And you stay on that level, right? You go in circles and nobody will tell you what they actually want or where's the beef in the data. But it's rather explorative, and you try a little bit, you find a little bit, and this is kind of where you end up. So the data warehouse development lifecycle is a data-driven development. It starts with the data, and you work on that data, and the more you know about the data, the easier it will be and the more effective it will be to design what you actually want to do with the data, right? And then once you understood what the requirements actually are, you can adjust the data warehouse, you can adjust the data you're collecting, you can adjust aggregation levels or something like that, right? And you start over again and start working with the new data, start working with the new. So it's kind of a spiral development methodology that are very typical to today's agile processing types. So what you do basically is you design and prototype, right? And then work with data, you deploy it, then you operate it, and then you enhance it, and this goes on in a spiral, basically advancement of working with your company data. So your decision support system is supposed to get better and better all the time. So first, for the design, you need to interview end users and ask them about what is interesting for them, what data would they like to see, what data do they usually look at, on what their decisions that are made last week or something were based, so you get an initial idea of what is there. You also analyze the architecture and the software components that are already there, right? So all the data systems that are already there. You define some key performance indicators where you want to end up, right? And then you try to map the decision-making process or known decisions that have been made to the data that was collected, right? You define all the schemas, you define what data you need, you define how the data is linked with each other. This is typical design stuff. And then immediately you go to the prototype phase and make it happen. So take some data warehousing software, implement your schema, load in the data so you can see what new requirements you will have to gather. You start deploying it. Deploying means that you develop documentation, that you train users in using it, that you train users in working with the data, but also the management process of the data. So how do you get the data? What are the limitations of what you get? Can you really go into the operative systems and extract data from there? Also the question, do you in some way hamper the functionality of operative systems while extracting data from them? Because putting too much load, you saw the CPU load of systems, putting too much load on an operative system can be very dangerous. You can make it crash, or you can slow it down such that the customers in the store take, I don't know, 10 minutes, 20 minutes at the cash register in the worst case, right? And this is not what you want. So look at what it actually does. Then comes the operation phase, where you have the day-to-day maintenance. You have this ETL process that we will talk about in detail. So the extraction, transformation of data, and the loading into the data warehouse. And finally, you have the enhancement process, where you look at hardware, where you look at physical components. Do you need more? Do you need more main memory, what do you actually do, what processes do you apply on the data warehouse, right, and what do you test the data warehouse against, right? And then you start over with the design phase and see what happened, see new requirements, design for these requirements, and start the circle again and again and again. That's basically how it develops over time. So when you actually operate the data warehouse, you can identify a couple of phases which are monitoring, extraction, transforming, loading, and analyzing. So this is the typical ETL process here, extraction, transforming, loading. And before that, you do basically the monitoring of the real data, of the OLTP data. You look at what the operative data is about. And this is why you do it. This is the analyzing of what comes out. I will give you a short insight into all of these phases, but we will go into them in detail next 2 or 3 lectures. So the monitoring is basically surveil the data sources. You look at how they're doing, how fresh the data is, and you identify everything that happens to your operative data that may be relevant to the data warehouse. So do you need to load new data in the data warehouse, or is everything still in a stable state, so you have learned nothing new? And the monitoring is the basic of what data do you load and when do you load it, right? So if a lot happens, if you monitor a lot of changes, then an intermediate load into the data warehouse may be asked for. But you know, if the data does not change at a really high rate, then maybe weekly updates may be perfectly okay, right? So it depends on what happens in your company to see how the data changes in the data warehouse. Same holds for different kinds of changes. You know, does data changes very, very severely? So are there strong changes in the data? Then reflecting that at a very early point in time in the data warehouse may be much better than waiting for the next week until loading it in a bulk, right? So if nothing changed in the data, so if you got more of the same people buying same things or something like that, then the data warehouse is still okay with the old information. So the decision will not be changed by the new data, basically, right? So this is kind of why you monitor the sources. There was a question?
Is the monitoring a pull or a push process? How is it triggered?
Well, that depends basically on what you do. Usually it's a pull process. Because the operative systems are not really interested in the data warehouse, right? They are interested in that they work, right? So what the Walmart guys built in the first place was a online transaction processing system, and it worked perfectly well, right? It worked perfectly well to get all the information from all the stores in the database, and this is all the operative data cares about. Right? And then comes somebody and puts a query on top of it that runs a 6-way join, you know, like, and then comes somebody who puts extraction mechanisms on top of it, right? And pulls out the data or aggregates the data, that puts stress on the system, right? So how it is actually done, it can be done either way. You can either say, well, it's better for the operative system to push it at some time slots where they don't have too much work anyway, whereas the load is kind of rather balanced, you know, like, and then why don't we push the data that we collected or the new data to the data warehouse and then be done with it, right? Or you can have it in a pull fashion where the data warehouse overnight, for example, or over the weekend says, okay, everything that has been done, everything that has been recorded during the last week, I will have it now, right? Usually, the important thing is that the guys have to talk to each other. The data warehousing guys and the OLTP guys are usually not the same department. And they have to talk to each other very seriously. Otherwise, it's doomed to failure. Okay, so there are some monitoring techniques. There's active mechanisms, so typical event condition action rules, where you have some kind of event can be time triggered, every night, can be each individual payment that is made, can be once an invoice is paid or something like that, whatever you find being a good event. And then you say, well, you could add a condition and say, okay, if the account sum is bigger than a certain number or something, so it does something to the warehouse, then transfer to economy account, or you just have this action. And this can also be used for monitoring. There are also replication mechanisms. So, for example, in Oracle, there are snapshots, or Oracle databases do snapshots of local data. And once it's changed, the snapshot is replaced. This is kind of similar to the view mechanism. In IBM DB2, the data replication maintains a materialized data destination table, and incrementally changes the materialized table is basically updated. So there are different possibilities to do it actually. There are also protocol-based mechanisms. So you can look into the logs for what to extract and what has changed, and how much has changed. And once the log has a certain size, you can extract the data and say, okay, this is a nice batch that I want to have in the warehouse now. On the other hand, protocols are usually maintained by the operating system. They may can come in various proprietary formats, and the operating system may actually deal with it in the way that seems advantageous. So basically, if the operating system decides to drop a log because it's full or whatever, right, then there's hardly anything you can do about it, and you lose data. So it's kind of tricky a little bit. And there are application-based mechanisms. This is the pull mechanisms, right? You have an application that basically pulls the data into the system and then uses timestamps in looking at what it already has gotten from the source, or data comparison, look at the last transactions and see when I find one transaction that I already have, then the chain is broken or something like that. So there are different possibilities. Then comes the extraction step. So you read the data that you considered during the monitoring stage to be new, to be relevant to your data warehouse, and insert it into some intermediate structure, which is called the staging area. The staging area is where the magic happens, where you prepare the data for being put into your data warehouse, where you make it consistent, where you transform everything, right? This is the staging area. And staging area, like if you have a lot of operative data and you use a weekly update level or something, you can imagine that the data is going to be quite big. So a staging area has to be quite big, and very often there's compression of the data involved makes it a little bit more handleable. The time point for performing extraction can be periodically, right? So every night or something like that. On request, you have something that changed, something event condition action like where something changed in a certain way, and then you request it. Can be event driven, right? Certain number of modifications have been done. It can be immediate. So, for example, consider a stock market broker or something like that. Once a week, getting the new data will definitely not be enough, but it has to be, once something changes every millisecond or something like that in the stock market, right? You need the updates, you need the new data, so that has to be done immediately. The extraction process itself is rather dependent on the hardware that you use, so there are different ways of actually doing it. Then you start within the staging area after you extracted the data from the sources to transform it. And transformation means basically that on one hand the quality of your data has to be right? There should be no mistakes in the data. In operative systems, due to creative use or due to simple typing errors or something, there may be data that is incorrect. The question is, how do you find that out? right? And there are several possibilities. So, for example, if you have the zip code of a city and you have the city name, then checking whether the zip code actually belongs to the city could be automatically done. You could look at email addresses, for example. You could look whether they have an @ sign in the middle, and so on, or whether they have known domain endings or something like that, right? So there's a lot of checks you can do to make sense of the data in a way, right? You have to look at what are key attributes. You have to look at data types of semantically similar data, so they should be in the same type. Even if they were designed in different systems, you have to look at encodings and whatever, right? So this is all transforming your data. And there's a lot of things in the term of data cleaning that you actually have to do. So you could calculate new values. So for example, you can have the net price, or you can have the price including the tax, which is just a simple conversion, but it's controlled redundancy. If this is done automatically, the redundancy will not be bad, right? You can aggregate things. You can, for example, have daily sums of purchases or sales, or you do it by customer or whatever. You can have measurements that are kind of in different areas, especially if you have multinational companies, right? This can be done quite easily. Well, the data cleaning is a very important step within transformation or before the actual transformation. So you check the sanity of the data. So for example, if something is delivered after it was ordered, that seems sensible. If something is delivered before it was ordered, that does not seem sensible. The question is always, how do you live with such conflicts, right? What do you do in terms of conflicts? Once you detect one, you can have people investigate. This is usually like manual interaction, where you ask somebody, oh, could that be, or is that sensible value in that data field, or something like that, or could you try to replace it by something else? Then the completeness of the data is kind of interesting. So how complete is your data? Are there many null values? Has everything been filled? So for example, if you have a new customer that purchases something, do you have the customer address? Do you have everything you need to work with the customer? You could look up city names or something like that in dictionaries and get gazetteers, where you know, does the city exist, or is that a typical name, or is that a name that seems to be rather strange? So I mean, many people will work with services on the web, right, where you have to register, and then you have the typical name of who@who.com or something like that, right, because you don't want to know to give your real data. Finding such entries and removing it from your customer database may be a good idea, right? So this is kind of the sanity that you're going into. One big help with these sanity things are regular expressions. So many data items follow a certain form, right? You can also check for duplicates. So if the same customer comes again and again and again and always has different addresses, that seems to be strange, you know, like you have to find out what it is. Also outlier detection, right? If you find somebody is 530 years old, given the age structure of your customer base, this should be an outlier, you know, like might indicate an error. Might be somebody who's really old who wants to buy something from you. But these are kind of things that you have to work with, and that usually have to be looked at by intelligent people. Then ETL, extract, transform, load. This is the loading. And loading is a very important process for the data warehouse to get the new data in, to get the clean data in. But usually it's large volumes of data. So you have to sneak it into the data warehouse without hampering the performance of the data warehouse, because you have the same problem here as with the transaction processing databases, right? Once you run the query or once you do maintenance on the database, you cannot do the usual operation, right? And this is the same with loading. So there's usually a split between the initial load, where you initially load all the company data into the data warehouse, and the periodical upkeeping of data, the integration of new data that derives, that is much smaller usually, because the initial load, this is all the data that is distributed over your company, and you need at one point to get it into the data warehouse to actually build the data warehouse, right? You always use bulk loaders for that, because single inserts, single line inserts, like will kill you performance-wise. But you have to put it into a format that is very nice to process, and then every big database company, every big vendor has a bulk loading process where all the indexes are dropped, where everything is kind of made so that the inserts can be performed very simple and very quickly. You usually optimize this process by parallelization, so you can load different chunks of the warehouse in parallel, given that you have the correct storage structures behind that, and the incremental actualization, so you try to find smaller portions of the data to load into the warehouse. Finally, you get to the analysis phase, and this is kind of the idea why you built the warehouse in the first place. You want to derive new information. You want to derive information. So what you need is the data access, and then you have typical queries, like how many sales did we have in this time span at this location, or how do the shops in Hannover and Braunschweig compare, is one doing better as the other, or in producing products, is one factory more efficient with the number of employees, or the total cost of production. These are the typical analysis queries, and what you can see is that all of these queries can be basically done with SQL, right? So you can build these queries rather easily in SQL. On the other hand, they may take very long. They are answerable by OLTP systems, but they may take very long because they usually involve a lot of joins and a lot of different structures and aggregations that have to be performed at query time, right? And this is kind of not what you want. So for OLAP, there are some analytical operations, right? So for example, in which district does a product group register the highest profit? You have to aggregate all the sales of the product group first. Then you have to look at it. You have to group it district-wise, and you have to look to maximize or to order it by the profit, something like that. You can detect changes, so you can kind of consider different time spans and look at the different results and how the market evolved, right? So what you get is less point queries, but rather queries that show you some trend or some development in your data, right? And also these queries can be done with SQL. I mean, they're not as easy to pose as these queries, but they can be done with SQL. They will take a lot of time, right? Again, so the data warehouse should be kind of prepared to deal with these queries by pre-aggregation, by clever means that we will talk about in the future lectures a little bit more. And finally, yes, please?
I have a question about the ETL process.
Yes.
I'm not quite sure if I understand this right.
Mm-hmm.
So you have three more or less separate
steps.
For example, servers where you have data, you have your operational data.
Yes.
And let's say every
weekday,
night,
every
night I put my data into the staging area.
Yes.
And then, I mean, so there's no load at the staging area in the weekdays in the normal time. So in this time I can maybe process the data, or just let's say every Saturday I will process all my data and transform it on every Saturday, and every Sunday then I will put all my transformed staging area data into my data.
Exactly. So basically the process is you really need an infrastructure to support that, because you cannot really do it on the operative system, neither should you do it on the actual data warehouse, right? Because you will slow either of them down. Right? So you need something in between. And since these data transformations are sometimes just, like conversions between different entities or data types, that's the easy part. But very often it's consistency checks. Very often is this really a customer? Or can it be that the store in Hamburg that sold 5 computers over the last month, right, now sells 500 a day, right? Is that reasonable? Is that so? You see that a lot of these problems can only be solved by interaction. So this is rather long running, right? And you definitely don't want to halt the operative system or the data warehouse for while you do that. So they are under different loads, and these loads do have different patterns, right? And also, there are some new, we will also talk about that, about real-time data warehousing. It's also kind of a bad idea with classical architectures, with classical server architectures, to put everything on one system, even if it's big enough. You could argue that, you have these spiky patterns in data warehousing, and you have the normal load by the OLTP system. So why don't you just buy a server that's twice as big and then put both on the system, right? But then you have a lot of free space or a lot of free processing time on your system, because the spikes don't fill up some places but don't fill up others. And making a good load balancing here is kind of difficult. So it's also a matter of hardware usage and the allocation of how to use it and when to use it. And so kind of mixing the spikes of different analysis systems is much easier than integrating it into the load of a system that has a strong base load, right? This is kind of the idea behind that. So last thing in analyzing is the data mining. This is one of the important parts of the lecture that will be with us the last 6 lectures, I think, where we really go into the data mining algorithms, in association rule mining, in clustering, in classification, in everything that's interesting, a decision tree induction or whatever, right? That tells you something about your data that you did not know yet, right? And tells you how to get that, how to identify hidden patterns, right? So one of the classic is, for example, that customers who buy wine also very often buy cheese. And the question is that true, right? And you might probably argue, yeah, I mean, wine and cheese go very well together, so in a lot of the Walmart sales, they should occur together, right? And that's actually true. They do occur together very often. But whereas this is very simple to say in something with wine and cheese, would you believe that beer 6-packs and Pampers, diapers go together very well? Fact is, they do. And these are the guys that kind of grab the diapers for the weekend, right, and a couple of them, and have the 6-pack because they can't go anywhere. They don't have parties, they don't go out because they have kids at home, right? So they buy a 6-pack, right? And this is kind of hidden. This is kind of more surprising. If you think about it, it becomes logical. But you would probably not have thought about it in the first place. You see it. But you have to see it first to know that it makes sense. And you will also pick up many signals that don't make sense at all, right? So you have to decide which is which and how to deal with them, right? Also for targeted marketing, of course, how does a typical iPad buyer look like, for example, right? So age group, where does people that use iPads usually live, like is it random, or are there certain areas where you say, I don't need to buy an iPad, to build an iPod store there because nobody will buy, right? It's not interesting for them. And as I said, we will talk about association rule mining, sequence pattern mining, classification, clustering. All the different techniques will be covered in detail in this lecture. To sum up, what I did today is give you a data warehousing overview. To put it simple, a data warehouse is a very big database that collects data for analytical tasks, for supporting management decisions. The data is extracted from an operational environment, and the idea is to put as less stress as possible on the operational environment, because OLTP is hard enough as it is without the data warehouse interfering, right? It's transformed, cleaned, and worked on in the staging area, and then loaded into the data warehouse. Typical usage scenarios are budgeting, enterprise resource planning, marketing campaigns, and so on. There's a load of applications where you need that things. The users of the data warehouse are decision support analysts, usually very skilled and very highly paid employees in almost every company today. So on the board level, you will find that in almost every big company nowadays, there's a CIO, there's a Chief Information Officer. And those are usually the guys that are directly in charge of the company's information. Because information within a company is considered to be a very valuable asset these days, as is the personnel, as is the product development, research kind of things, right? But this point of putting information at the top level, at the board level, is rather new. That has been a development of the last 10, 15 years, right? Before that, the information flow in the company was considered to be obvious and not to be very interesting. But this has definitely changed. Since the requirement of the actual data analysis process are not known at the beginning, the life cycle is kind of flipped around. You don't start from the requirements and build the system. You first build the system, then start playing around with the data, start discovering the data, new insights, and then you know what to build, what your requirements actually are, and you build services on top of that that actually show what you want to do. So what's next over the next couple of weeks? We will do two parts of the lecture. The one is the data warehousing, the other one is the data mining. It's kind of half-half. In the data warehousing, we will cover the typical architectures. We will talk about data modeling, what is different to the normal ER scale modeling that I kept talking about in relational databases. We will talk about optimization, so the typical database topics, indexing of data, materializing data, partitioning strategies, blah, blah, blah. We will talk about queries, so OLAP is necessarily different to support this kind of different queries than classical SQL. So we'll talk about SQL extensions in that area and multidimensional query languages. And then we will talk about the ETL process in detail to really show you what it is about, because this is one of the important processes of preparing the data, of working with the data. And I think that many of the questions that today were only briefly addressed will become clear. Data mining, we will talk about the mining of rules, sequence patterns, time series, including some ideas about how to deal with the real-world data and how to deal with timely data. We will talk about machine learning techniques, so classification, decision trees, statistical approaches. Support vector machines is kind of one of the typical techniques that we will talk about. And we will talk about unsupervised machine learning techniques, so for example clustering, k-means, hierarchical clusterings, all these algorithms will be covered in this lecture. So after you took this lecture, you have a very comprehensive view on operations, on big data in a company. And then you will find out that this is not only interesting for the company, but it applies to all kinds of data. So also scientific databases, right? Bioinformation, whatever you want is kind of covered by these typical applications. So you can do a lot of things with that, up to natural language processing or whatever you want to. You will find these techniques are very broad and can be applied in many scenarios, right? Questions? Everybody happy? Good. Next lecture, data warehousing architecture. We'll talk a little bit about the basic architecture, storage models, layers, middleware, everything that you need to know from an architectural point of view to build the data warehouse. Thanks for the attention.